Hi everyone, your favorite teacher is here. Haha, just kidding. How are you today? I hope all of you in good health because today we are going to learn some very interesting topic which is the applications of Pascal's principle in 15 minutes. Okay, so our learning area today is still in pressure, subtopic Pascal's principle, and our learning outcome for today is communicate about applications of Pascal's principle. But before that, let us recall what we have learned last week. What is Pascal's principle? Pascal's law states that when there is an increase in pressure at any point in a confined fluid, there is an equal increase at every other point in the container. So what is the formula used? Okay, so the formula is F1 divided by A1 is equal to F2 divided by A2. Alright, so F1 is refers to the input formula, right? Sorry, input force right here. And A1 is equal to this piston area, small piston area. F2 is it refers to the output force, and A2 is refers to the large piston area. Where do we apply Pascal's concept? Okay, so let's start with a very simple example that we use every day, which is toothpaste. So do you have a family member who use your toothpaste? Doesn't it make you angry when they don't squeeze it from the bottom? The fact that you can squeeze it from the bottom and still have the toothpaste came out is an example of fluid principle. Why? Because toothpaste is a fluid that is enclosed in a tube with a small opening at one end, and the pressure applied to the tube is transmitted equally throughout the toothpaste. When the pressure reaches the open end, it forces the toothpaste out through the opening. Okay, now we are going to look at the bigger picture of the applications of Pascal's principle. There are a lot of applications that widely use this principle, but we are going to focus on these two, which is hydraulic jack and the other one is hydraulic brake. Before we go deeper about hydraulic jack and hydraulic brake, first we must know what is a hydraulic system. To define simply, hydraulic system function and perform tasks through using a fluid that is pressurized. In a hydraulic system, pressure applied to a contained fluid at any point is transmitted undiminished. That pressurized fluid acts upon every part of the section of a containing vessel and creates force or power. So the five basic components of a hydraulic system are reservoir oil tank, piping, hydraulic pump, valve, and also power source. Now that we know what is hydraulic and the basic components, let's see our first application of Pascal's principle, which is hydraulic jack. Almost everyone has changed a tire at some point in their life. While a spare tire is acknowledged as a necessity, the second most important tool for the job is a jack. Without it, there is no way to lift the vehicles off the ground. So floor jacks are mainly used in the automotive industry to lift vehicles or part of the cars off the ground during repair or routine maintenance. A hydraulic jack uses a liquid which is incompressible that is forced into a cylinder by a pump plunger. Oil is used since it is self-lubricating and stable. What are the main components of hydraulic jack? Okay, so the main components of hydraulic jacks and their functions are, okay, this one at the bottom here is the reservoir. The reservoir is a vessel that holds hydraulic fluid which will be used to transfer applied pressure from the pump to the big piston. And this one right here is a one-way valve. It is to allow fluid flow in one direction and automatically prevent backflow. Okay, right here is the small piston. It transmits force to the big piston. The force is transmitted by a fluid. And this one right here is the big piston. The function is to lift load when enough pressure built within cylinder. Okay, now that we already know the function of each component, let us see how hydraulic jack works. Okay, first, when the wrench moves upward, it drives the small piston upward. Then, the oil in the tank is sucked into the lower part of the small piston through tubing and one-way valve. Okay, so that one is occurs here. This is the reservoir, and the oil is sucked through this one-way valve right here. Okay, next. When the wrench presses down, the small piston is driven downward and the oil in the lower part of the tank and the small piston is blocked by the one-way valve. Okay, when this happens, when the oil is already through this valve, the valve is closed and blocked, so the oil remain right here under the small piston area. Okay, next, what happened is the oil in the lower part of the small piston is pressed into the lower part of the big piston through the internal oil pump and the one-way valve. Okay, so this one is occur right here. Okay, so the oil is pressed into the lower part of the big piston right here through this one-way valve, second valve. Okay, next what happened is the oil pressure produced manually is squeezed into the large piston. Okay, so this one occurs right here. Okay, next what happened is so long as the swing handle is switched back and forth when working, the oil pressure increase in the cylinder. So the piston and the weight above the piston are forced to move upward together. Okay, so this one occurs right here. So long as the swing is moved back and forth, so the oil pressure in this area is increased, that the piston and the weight above are forced to move upward together. Okay, so lastly, to release the pressure of the jack, the one-way valve is simply released so that the oil flows back out of the jack cylinder. Okay, this is the release valve. So if you want the oil to flows back out of the jack cylinder into the reservoir, simply just relieve this release valve. Okay. Okay, in order for you to get a clearer picture, let's watch this animation. Alright, so if you have any question, simply pause this video, write down your question, and you can ask me later on. Now we are going to look at our second application of Pascal's principle, which is hydraulic brake. A hydraulic brake is an arrangement of braking mechanism which uses brake fluid to transfer pressure from the controlling mechanism to the braking mechanism. Hydraulic brake used not only in car brake system but also in cranes and elevators, aeroplane, and also in mining vehicles. And the uses and application for hydraulic brakes are endless and all use similar system and components. Imagine how much force you need to stop a fast-moving car. Simply pressing with your foot would not generate enough force to apply to all four brake hard enough to bring you quickly to a stop. That's why brake use hydraulic, a system of fluid-filled pipes that can multiply force and transmit it easily from one place to another. Now let's see how hydraulic brake works. Okay, first, your foot push on the brake pedal right here, and then as the pedal moves down, it push a lever, a kind of simple machine, increasing your pushing force. Okay, so this one right here is the lever. Okay, then what happened next is the lever push a piston into a narrow cylinder filled with hydraulic brake fluid. As the piston moves into the cylinder, it squeezes hydraulic fluid out of the end. Okay, so this one occurs right here. This is the small piston. Okay, then the brake fluid squirts down a long thin pipe until it reaches another cylinder at the wheel, which is much wider. Then, when the fluid enters the cylinder, it pushes the piston in the wider cylinder with greatly increased force. Okay, so that one occurs right here. The fluid is already entered this wider cylinder with a great force. Okay, then the piston pushes the brake pad towards the brake disc. The brake pad is the green one, this one right here, and the brake disc is the gray one, this one. Okay, so when the brake pad touches the brake disc, the friction between the two generates heat, and the friction slows down the outer wheel and tire, thus stopping the car. This is one of the STEM project. Let's watch this short video in order for you to get a clearer picture on the hydraulic brake mechanism. Okay, that video shows the basic principle of a hydraulic braking system, while in practice there's a little bit more to it because the brake pedal actually operates four separate hydraulic lines running to all four wheels. Brake fluid must have certain characteristics and meet certain quality standards for the braking system to work properly. So what are the characteristics of a brake fluid? First, brake fluid must maintain constant viscosity under wide range temperature. Second, it must have high boiling point to avoid vaporizing in the lines. Third one is corrosion. For this one, additive, which is corrosion inhibitors, are added to the base fluid. And the last one is compressibility. Brake fluid must maintain a low level of compressibility. Okay. Why this hydraulic system used widely is because of disadvantages. Okay, first, hydraulic system is an efficient transmitter of power for many reasons. Second, simple levers and push button make it easy to start, stop, accelerate, and also decelerate. It also provides a constant force regardless of change in speed. It is simple, safe, and economical because they use fewer moving parts compared to mechanical and electrical system, and also it is easier to maintain. However, hydraulic systems also have some drawbacks, which is handling hydraulic fluids is messy and it can be difficult to totally get rid of leaks in a hydraulic system. Safety measure is important when handling hydraulic fluid as too much exposure can lead to health issues. And the last one is hydraulic fluids are also corrosive, but some types are less than others. Okay, and to keep your hydraulic system in its prime, periodically check hydraulic system for leaks, lubricate when necessary, and change filters and seals as required. Okay, so the conclusion for today's lessons are, how come there is no conclusions? Well, I think it will be better if you give me the conclusion based on what you have watched in this video. Alright, so here's some question that I prepared for you to check your understanding. Number one is, why is liquid used in hydraulic instead of gas? And the second one is, why is it dangerous if air bubble is trapped in the brake fluid of a braking system. So in the next class, I want to know your answer to this question. And for your attendance, kindly scan this QR code and fill in your name, metric number, and also your conclusion for our lesson today. With that, I end my presentation. Thanks for watching and have a good day, everyone.